Hi, in this video, we're going to take a look at different types of static routes. Okay, so the following types of both IPv4 and IPv6 static routes we'll be discussing, at least introducing here and in later videos a little bit more, but we'll talk about a standard static route, a default static route, a summary static route, a floating static route, and something I'm adding is something called a discard route. Okay, so for now, don't worry about the syntax we're going to see. We're going to talk more about that when we, in the video on configuring IPv4 static routes and configuring IPv6 static routes. But you'll see that the syntax is pretty easy to follow here. So here is a standard static route and pretty much the syntax we're going to be using for all static routes. So for example, here we have router R2 that only has one path to reach the 172.16.3.0/24 network. So we're going to put a static route on R2 pointing towards R1. Okay, so here's the actual static route. And it starts with an IPv4 static route. It starts with IP route. IPv6 static route is IPv6 route. And then we have the destination network and subnet mask. An IPv6 would be a prefix and prefix length. And then typically a next hop IP address. So the next hop router. Now, technically, this does not have to be a next hop IP address. It just has to be a reachable IP address. But usually, the vast majority of the cases, you're going to want this to be the next hop IP address. Okay, it's really that simple. Okay, there's also default static routes. So here we have router R1 that wants to have a default gateway on a host. Basically, if R1 doesn't have a more specific route in its routing table for the other networks it knows about, it wants to send it onto R2, maybe it's ISP and onto the internet. So for a default route, again, IP route, we use quad 0, quad 0. This will be discussed more later when we do configuration of IPv4 and IPv6 routes. And again, the next hop IP address. Pretty straightforward. Okay, a summary static route. So summary static route, here we can see that R1 has 4 static routes to reach these 4 remote networks. Okay. So a summary static route is when we want to reduce the number of routes in the routing table. That's always our goal to do. Smaller routing tables, the better. We'll talk more about this in the video on summary static routes. But anyway, we want to reduce the number of routes in the routing table. And because these 4 routes have some set of contiguous leftmost bits, as you can see, they're all at least all starting with 172. And they're all going via the same next hop IP address, that these routes can be summarized into a single route. Okay, so what we would do is remove those 4 individual static routes. By the way, we do that with the no IP route command. And then we give a summary static route, a single route, indicating how to reach all of those networks. And again, we'll talk more about this in a later video when we talk about configuring summary routes. Okay, there's also what is known as a floating static route. So for example here, the branch office might be using the private wide area network connection, private circuit here, to reach headquarters. Okay. Well, a floating static route is used as a backup path when the primary either static route or dynamic route fails. Okay, so if for some reason we no longer have connection over our private WAN, we can actually, maybe in this case, use the connection over perhaps the less secure, but we can secure it with a VPN, but using, in this case, our internet connection. Okay, and we'll talk more about this a little later, but basically the way we do this is in the static route, the floating static route, we add a higher administrative distance to the end of the configuration. Basically what we have here is if we are using EIGRP over our private WAN, and EIGRP has an administrative distance of 90. So if we have both, if branch office says, hey, I know how to get to HQ, the 10.0.0.0/8 network, via both EIGRP, well, that would be via the private LAN, but using EIGRP, which has an administrative distance of 90, or over this internet connection, public internet connection, using a static route. Well, the static route in this case, by default, it would have 1. That's the default administrative distance for a static route. Okay, and that would take precedence over EIGRP. But because we've changed the administrative distance of the floating static route to be 100, it actually has a higher administrative distance. So EIGRP route with an administrative distance of 90 is what will be offered to the routing table. Okay, if that happens to fail, then this floating static route, the static route with a higher administrative distance out of 100 will then be offered to the routing table. If the EIGRP route over the public WAN came back up, then the floating static route with a administrative distance of 100 would be removed, and the EIGRP route with an administrative distance of 90 would be installed. Okay. All right. Discard route. This is something I always like to include. Let me talk a little bit about a discard route. Okay. So here we have R1 is part of its network, and I'm using private address space here for everything because that's really best practice when we're doing documentation or teaching or whatever. But let's say this is a public IPv4 address, 172.16.0.0/16. So this network here that R1 belongs to, it's the gateway router to the internet, but it belongs to this network here that has this public address space. So anything that is part of this public address space, like 172.16.4.0/24, would be contained within this routing domain. So the edge router here says, look, if the destination IPv4 address is for a network that falls within this address space, but is not in my routing table, okay, then it doesn't want to send that packet to the ISP router R2. Because what will R2 do? R2 would just simply route that traffic back. Here we have R2 says, look, to reach anything in 172.16.0.0/16, anything that the first 16 bits, 172.16.0.0, I'm just sending them to you. So what we would want on R1 is to have something called a discard route. So what this is, IP route, okay, we take our entire address space and we say, look, if it does not match a more specific route in our routing domain, like 172.16.4.0/24, this would be in our routing table. If I don't have a more specific route for it, then what I want to do is send it to the bit bucket. I need to discard it. What I don't want to do is send it to, if I have a default route, I don't want to be sending it to the R2 router, the ISP, because they're just going to send it back to us, and all we're going to do is have a routing loop, and that's going to continue until the time to live field expires on that packet or packets. Okay, so what this does is that this keeps our packets within our network. If R1 gets a packet for some reason somebody is trying to ping an IP address for a network that does not, that we really don't, this 172.16, it's part of our 172.16.0.0 address space, but doesn't physically exist in our network, we don't want to be sending that to the ISP. We want to be the ones to drop it, okay? call that a discard route. Okay, so these are just kind of an introduction to different types of static routes. We'll be talking more about configuring static routes and all this good stuff in later videos.